So in the two YouTube videos that we shared at the beginning of class, we learned some theorems that involve inequalities in triangles. So the first one was called the triangle inequality theorem. Okay, and in that first video, we saw where we had some specific lengths that we wanted to make a triangle out of, and we did some experimenting to see could we make a triangle out of these lengths. And what we found out is the relationship has to be such that any two sides in a triangle have to be greater than the third. And that's what the triangle inequality theorem says. It says the sum of any two sides of a triangle must be greater than the third when added together. Well, we also found a shortcut to try to figure out, like if we have three side lengths and we want to know, hey, will it make a triangle? What we had to do was take the two smaller ones. So we took the sum of the two small. This might be a good idea to add this to your notes here. Plus the small. So the two smaller have to be greater than the large side. So that's a really quick test. We should be able to just look at these sets of numbers in example 1 and be able to tell right away, hey, is this going to make a triangle or is it not? Which is a lot easier than actually getting out, say, some straws or something and cutting them to these measures and then trying to put them together to make a triangle. So it's a nice quick test. So looking at example 1A, 4, 8, and 10. Well, the two smaller ones are the 4 and the 8. And what I want to know is 4 plus 8 bigger than 10, right? Is it? Question mark? Well, is it bigger? It is, right? So we know that it's bigger. Oops, I'm going to erase that. So that means, since it is, then it's yes. It will make a triangle. Okay? Has to be greater. Now, make sure you're not just always picking the first two. You got to because they might not always put them in side length order. But in this first and second case, they did. So 7 and 9 are the two smaller. So we add the two small together. And then we want to compare it to the larger one. Well, 7 plus 9 is 16, right? But is 16 greater than 18? Nope. So that's a no. It's not greater than 18. So this won't make a triangle. It'll be one of those ones where you basically have that one long side. You try to attach the two short sides to either end, and as you start angling them towards each other, they just flop down, right? And then there's a little gap between them. Letter C, 12, 4, and 16. Okay, so this time they didn't put them in size order. So, but the two smaller ones are the 4 and the 12, and we want to compare them to 16, okay? And 4 plus 12 is 16, right? And so is 16 greater than 16? Nope. It's actually equal to it, and it's got to be greater than. Notice these are all greater than symbols. They're not greater than or equal to, so this is another no. So they can't even equal each other. It has to be greater than. Okay? So this is a good one for you. Try. Just give it a try. And then we'll take a second. See if you think it makes a triangle. And the answer is yes, it does. Because I added the two smaller together, they added up to 32, and it was greater than the largest, so this is a yes. Okay, so then we talked about how to find the range of values of the missing side. Now, there's all kinds of different triangles, right? There's isosceles triangles, equilateral triangles, right triangles. And the only kind of triangle you can find the exact side length, if you know two, is if it's a right triangle, because there's Pythagorean's theorem, right? But in general, we don't know like whether this is obtuse, acute. We don't know if it's equilateral, isosceles, none of that, right? So the best we can do here is get a range of the third side. So the third side, we learned that it has to be, actually I'll write this at the top. So the third side had to be less than the sum of the two others. This might be a good idea to write that on your notes. And got to be greater than the difference between the two others. And specifically with the difference, you have to make sure you subtract the smaller from the larger, right? Because otherwise you get a negative. So we've got, on the one side, we've got 12, and the other we have 10. So it'd be less than 12 plus 10. But it's got to be greater than 12 minus 10. So that means that third side has to be third side has to be less than 22, but greater than 2. And if I'm really honest, this theorem is my least favorite, and I do have favorites, but it's my least favorite geometry theorem, and the reason why is it doesn't really tell us a whole lot. Oh, big deal, wow, it's to make a triangle, you can be anywhere between 2 and 22. Can't be 2, can't be 22, but anywhere in between there. But it doesn't really tell, that kind of doesn't really narrow it down, right? But it is a theorem, so that's what we're examining it today. So it just basically gives you a range of values. Now, if you had a really, really small side, like it was closer to 2, then you'd have a scenario that looks like the one that in the drawing, right? But if we had one that third side was even bigger and you expanded it way out, it would actually make it into an acute triangle, whereas right now it's an obtuse triangle. We've got a triangle, or the biggest angle in it is bigger than 90 degrees, so that's an obtuse triangle. Okay, let's look at maybe just a couple more. So let's look at B. Okay, so B, the third side, we just want to add the two sides. So that means it's going to have to be less than 30, but greater than 0. Because see, those two sides are the same. So if you subtract them, you get 0, right? So our third side would be anywhere between 0 and 30. All right, let's just try one more. I want you guys to give C a try and find the range of values for X. So instead of saying third side, you could just use what they call the third side, which is X. So you're going to say X is less than something, but greater than something. Okay, so you just got to figure out what those somethings are. And has to be less than 35 and greater than 21 minus 14, which is 7. So anywhere between 7 and 35, not including those two numbers, so let's say 7.1 would work, or 34.9 would work, or anything in between there as long as it's bigger than 7 and at the same time less than 35. So I think with all the examples we saw in the video and 3 tried here, we can cross this one out and move on. Now we also saw in the video, in the second video, we saw a relationship between how big an angle is in a triangle and how big the opposite side is. So what that lets us to do is compare like side lengths based on the angle that's across from them. So that's called the side angle relationship, but he actually called it the hinge theorem. And I think it helps to call it the hinge theorem because it reminds me of like the hinge of a door. Like the bigger the opening is, like the wider, you know, like as far as the angle goes, the wider that door opening is, you can walk through it, right? So the hinge theorem. So looking at these examples, what we want to do is be able to tell what is the biggest angle and then what's the smallest angle. So we'll be asked to order them, like put them in order from least to greatest. So I'm going to set up kind of a little format to put our answers. We want to go the smallest, then the largest at the end. So that would be small, medium, and large. Sometimes they want it largest to smallest, but in this case they want us to put the smallest angle first. Now these angles all look really close, and the reason why they do is look how close the angle measures are, or the side lengths are. The side lengths are only like 1 apart. So of course the angles are going to be really close in measure. And so how do we know which one is the smallest? So the easiest thing to do to put these in order is to now order the sides first. So the smallest side is this one, right? And if that's the smallest side, then across from it is the smallest angle. So that means the smallest angle would be C. Now this is the medium size side, right? That's the one in the middle, right? So the middle angle must be across from it. It would be B. And then the largest would be across from the largest side, and that would be angle A. If you want to throw an angle symbol in there, you can. Okay? So all you have to really do is just look at and order the sides, and then the angle across from them will go in that same order. So we'll try one more and then have you try one. So on B, we want to go smallest to largest. So again, we're putting them in size order from in ascending order, right? So, but just be careful because depending on the question, they might tell you a different order. So if you did it in this order every time and they ask you for greatest to smallest, then it would be completely wrong, right? You'd be the complete opposite direction. So just make sure you're paying close attention. So they want smallest here, okay? So the smallest side is this side right here, right? So that means across from it's going to be the smallest angle. Okay, so I'll just, that will be C. Get this out of the way because it's in the way of my answer blank. So then the medium side is this one, which means the medium angle must be over here at A. Okay. And then the only thing that's left is the final angle, which is B, and of course B is across from the biggest side, and so of course that's got to be the biggest angle. So you think about that opening that you would make between the sides that are 10 and 12, the bigger you make that opening, the bigger the side across from it has to be to close that triangle off, right? So this makes real, like, kind of logical sense. It also makes very, like, concrete sense when you imagine it in your mind. And making that angle bigger, the side across from it has to be bigger, okay? So you go ahead and try C. We'll pause for a second, give C a try, and then we'll move on to our final questions. So we'll skip D again. I think we have enough examples. Okay, so our largest angle is C because it's across from the biggest side, right? Our smallest angle is going to be across from our smallest side, and then of course the middle angle goes across from the middle. It's the one that's left over, which would be angle B. Okay, so angle A, B, C. This time it goes in alphabetical order, so that's great. And our final example. So this theorem actually works in the reverse as well. So when you think about the bigger that you make an angle, the bigger the side opposite. But that same thing goes that the bigger the angle is, the bigger the side that's across from it is. So if we know all three angles in a triangle, or even if we know two angles, because we can use the triangle sum to find the third, we can then figure out the order that the sides have to go in. So for this first one, notice we have angles that are 30, 50, and 100. So if they ask you to put the sides in least to greatest, so again, they want us to do small to large. So the smallest, medium, and then the largest side. So the smallest side, I would just have to go across from the smallest angle, right? So the smallest angle is 30. So because that opening is so small, the side across from it's going to be small. And that's segment CB, okay? Now the medium one's going to be across from the medium angle, so that medium angle is 50 degrees. Across from that would be your middle length side. And your largest would of course be AC. A lot of times your triangles, you'll be able to just tell by looking at them, but this is how you get your concrete proof, is you actually look at the angles, because in this one, the way the triangle is drawn, you can absolutely tell that the smallest side is CV and the largest is AC just by looking at them. Just you can have, your eye will detect the difference in the lengths, right? But then you'll come across some that are very close, like in D. It looks like AC and BC are very close in length. So the only way to know for sure, because we don't ever want to assume, is to really look at the angles. And the reason why those sides are really close in length is because look at those angles. One is 70, 165. Okay, so they're really close in measure, so the sides across them are going to be very close. So the smallest side is going to be the one that's across from the small angle. So that's AB. Then the medium one will be across from the medium angle. So that one that's in the middle is 65 degrees. So that means AC must be the side in the middle. And then finally, the largest is BC, or CB. You can call it either way you want. Okay? So pretty straightforward, pretty easy, right? We are not even going to look at C because that one is so very obvious, right? Well, I mean, I guess 5 degrees and 15 degrees are really close. But I specifically want to look at D because D is a right triangle. And we've been talking about right triangles and how the biggest side is always the hypotenuse, right? We call it the hypotenuse. And it's always the one across from the right angle. And the reason why that is because the 90-degree angle, it has to be the biggest angle in the triangle, right? Because that's already half of the 180 degrees that you have for all the angles to add to. So putting these in order, the smallest side would be the one across from 30. Okay. The medium one would be the one that's across from 60, which is BC. And then the largest one is that hypotenuse, which is always the case in a right triangle, and that's AB. Okay? And that actually does it for the lesson. That's pretty straightforward. It's just this whole relationship between the angles and the side across from them, and then the requirements for links to connect and make a triangle. So that does it for today's lesson. I'll see you in class.